Okay, I think we're live. Hello, everybody out there. Here I am again. This time on a different subject. I pray that all is well with you guys. Um, I've literally been spending the last maybe 2 to 3 weeks working with some middle schoolers, middle schoolers, I should say, between the ages of 7 to 13 in math, as well as English and English language arts and the like. But it's pretty interesting what we're teaching now in core mathematics, and most teachers will know exactly what I'm talking about when I say core academy or core math that's being taught. And it's really the basics that our young people need. They are so much wiser now, and just I mean, they never seem to amaze me. And so I'm just wanting to show you guys if you have second, third, fourth, fifth grader, and they're learning how to multiply. Um, this past Saturday, I had the occasion to teach my kindergarten student who I've had since he was 4 years old. Um, but I missed seeing him for a couple of weeks, and we reconnected on Saturday, and I was amazed at how much he had been doing since I last saw him. He hated subtraction last time we talked. He's like, "I can't do it, I can't do it." And this particular time, this past Saturday, he was skip counting forward by twos and skip counting backwards by twos. So, of course, when you skip count forward, you're adding, and when you skip count backwards, you're taking away, you're subtracting. And he was loving it to and from 100 both ways. And so we practiced a few subtraction problems, and he was on the money every single time. And so I thought, let me just teach him a little bit about multiplication basics. And at the age of 5 years old, I started to teach him how to multiply by using a skip count method. And so we went all the way up to the 11s, and we skip counted from 1 to 11 times 12 for every digit in the timetable, from ones to twos to threes to fours, fives, sixes, all the way up to 11. Well, um, I've been also teaching these middle schoolers how to multiply 2 digits by 2 digits, 3 digits by 3 digits, and more. 3 by 2, 3 by 3, 2 by 2. And there's a really easy method. Let me just show you. Um, this is what we learned when we were growing up, right? So if we have, let's take the number 44. This is a bad pen, so I'm going to find a better pen, hopefully, and write with that. If we take the number 44 and multiply it times 15, this is what we learned. 4 times 5, of course, is 20. Carry, which we call regrouping. Carry the 2. 4 times 5 is 20 plus 2 is 22, right? And then we have 4 times 1 is 4. 4 times 1 is 4. We add all of that together, and we get something that looks like this number, 660, using long arithmetic, using long multiplication. That's something that we grew up with when we were younger. That was the way we learned. Now we are teaching something called an area model. And if you're not familiar with it, take notes. This is what I do every day. I use modeling. We use modeling for arithmetic. We use modeling for subtraction. We use modeling for multiplication and modeling with partial quotients for division. It really is fun, actually. And your students could probably teach you a little bit. But here we go. Let's just take 44 times 15. And one of the things that we have to recognize is prior to this lesson in multiplication, we would have had a multiplication breakdown of what these numbers represent, what the placements are of these numbers. So with two-digit math, you're looking at tens and ones. So if we were to rewrite the number 44, 44 would be written as 4 tens and 4 ones. And 15 is written as 1 tens and 5 ones. So it's a box that kind of looks like that. Okay. So of course, 44 is 40 plus 4. So 40 represents your 4 tens and 4 represents your 4 ones. And then if we're looking at 15, let me show you this again. If we're looking at 15, then 15 is represented by 1 tens in the placement and 5 ones. So then we take a look at multiplying. We create the product. And that would be, and something else that, when you're dealing with multiples of tens and arithmetic, the easiest way to do multiple of 10 without even thinking about it, most of us know it without looking at it. You multiply the two first numbers, and then you count the number of zeros that's between the numbers that you're multiplying. And that gives you the number of zeros that comes behind the product of the two first numbers. So 4 times 1, of course, is 4. Easy enough. You got 2 zeros, it becomes 400. Then you have 4 times 1 again. Here in the ones column, 4 times 1 is 4, and you add 1 zero. So now you have, without even thinking about it, you would just normally write 40. 4 times 10 is 40. Yay. Now, if we're looking at 40 times 5, okay? So 40 times 5. What is 4 times 5? 4 times 5 is what? 20. How many zeros do we have between 40 and 5? Just one. So we add a 0 to the back. Easy, easy speasy. 200. Then we take 5 times 4. Of course, that's 20. So this is what our area model looks like for multiplication. Now what you say, well, this is what? You add the numbers in the box. You can either add across or add down, whatever's easy. If you add across, 400 plus 40 is 440. 200 plus 20 is 220. And let me show you what that looks like. See? Add across 400 plus 40, 440. 200 plus 20, 220. Add those numbers, 660. And 660 represents your product of 44 times 15. Looks like I'm glitching a little bit. Hopefully not. But anyway, that's how you do that. And if you were to look at what the formulas represent, this is what goes in each of those boxes. 40 times 10, 4 times 10. 40 times 5, 4 times 5. Add across, and then add down. Product is 660. Isn't that neat? You can use that model for any number of digits that you have. So if you had to do something with 3x2s, it works the same way as 2x2s. I'm just going to show you this. I'm not going to go through it, but I'm going to show it to you and tell you that, of course, this is 519 times 23. Your 519 represented is 510 and 9. Your 23 is represented 20 and 3. And then you have your products. First one, 500 times 20. Then you get 20 times 10. Then you get 20 times 9. And the same for the second row. 3 times 500. 10 times 3. 9 times 3. Add across. Add across. Add down. Or you can just add all 6 numbers. It's just easier to teach the younger ones. They can sight read that and add it up in their mind and not skip a beat. Then they would add these numbers down. So that's just a real quick and easy method. Thought I'd just share that with you. Yep, I've got a whole bunch of those models in my phone. They're a lot of fun. And when the children get it, they love it. I had a 4th grader tonight, and he's like, "Yes!" I called him a ninja because he likes ninjas, but when he got it, he got it. And his mom immediately responded, "This is awesome," because they had not been able to explain it. So that's it, real simple. Maybe sometime later I'll do another model and show you some other things. I just did exponents and the order of operations, which is a lot of fun for a lot of people. But the order of operations could get you if you don't follow the right order. I might do something like this on my Facebook page and let you guys guess at what the order of operation is. Um, but anyway, I thought I'd just throw that out there. You guys have fun. Happy modeling. See you later.